Alrighty, so in this video, we're going to go through some examples of using Pythagorean's theorem. You've already seen a couple in the vocab, so you have a good idea what we're doing here. As a reminder, the longest side is always the hypotenuse. So if I give you three numbers, to check it, which we'll do later here, the longest number, the biggest number is always going to be the hypotenuse. This one we're going to actually solve for the hypotenuse. It's the easiest kind here. We can see that we have 6 and 8 for our sides. So that means A will be 6 and B will be 8. So 6 squared plus 8 squared equals C squared. So it's 36 plus 64 equals C squared. So 100 equals C squared. So C is the square root of 100, which we all know, again, is 10. So it means what number times itself. So the answer is going to be 10 centimeters in this case. Going to class kick, your turn to work a couple. When I do these, I always like to draw a picture. So we've got right triangle here, and this says the legs are 3 and 4 feet. So 3 feet and 4 feet, and again, C is the hypotenuse. So we'll have 4 squared plus 3 squared equals C squared. So that's 16 plus 9 equals C squared. So C squared does equal 25. There we go. And so C then is the square root of 25, or it is 5. In this case, label is feet. Don't forget the label there. That is important. Okay, so on this next one, I've given you the hypotenuse and a leg. So we'll draw a picture here. My right triangle. I've given you a leg of 12, the hypotenuse of 15 meters, and it's going to be A or B, doesn't really matter, that I'm going to be solving for. So that means we're going to have A squared plus 12 squared. Again, the legs go here, A and B, equals 15 squared. So A squared plus 12 squared, which is 144, equals 15 squared, which is 225. Subtract that 144, because we're trying to get the A by itself, so subtract that from both sides. And A squared equals 81. So A then is the square root of 81, which we all know is 9, because 9 times 9 is 81. And our label is going to be meters. So A is 9 meters. Continue here for more examples. Sometimes these aren't going to come out super nice for you. So the example here is A squared plus B squared, again is C squared. And we can see here that, again, we're missing one of the legs, so C is the hypotenuse over here. So 6 squared plus x squared, so I made it B, obviously, equals 9 squared. So 6 squared, that's 6 times 6 is 36. Leaving the x squared alone, 9 times 9 is 81. Now, at this point here, I'm going to write this out here. So we have 36 plus x squared equals 81. So subtract our 36 from both sides. So x squared is going to be 45. Now the thing is, it means x is the square root of 45. But 45 doesn't have a perfect square, right? It's not like it's 36 or 81, things like the 25. So square root of 45, remember way back earlier in the year we talked about, well, where does that fall? Well, I know that the square root of 36 is 6, right? And I know that the square root of 49 is 7. So square root of 45 falls somewhere in here, so it's somewhere between 6 and 7. You could use the button on your calculator, and find out, but it's going to be close to 7. So it's 6 point something. Again, here we go. Use a calculator. 6.708, goes on forever. So it's about 7. So pause, head into class kick. There's a couple for you there. Alrighty, so right triangle. So we'll draw another picture here. With the length of the hypotenuse is 15 meters. And the length of one of the legs is 8. I don't know the other one. Again, it could be A, B, you decide. So we have x squared plus 8 squared equals that hypotenuse of 15 squared. So x squared plus 64, 8 times 8 is 64, equals 225. Subtract our 64 from both sides, and x squared is 161. So x is the square root of 161, which you could put in a calculator if you want to. That's going to be 12.68, so it's about 13. So again, the exact answer, if you used a calculator, not exact rather, but is 12.67. But again, we do know that this falls between the square root of 144, which is the number 12, and the square root of 169, which is the number 13. So it's obviously, we're right, it's been in between 12 and 13. Continue here for another example. So I think this problem gets a little convoluted here. I'm going to alter the picture a little bit for you. I'm going to draw a line down the middle here so we can see a right triangle over here. Alrighty, so taking a look, it says the carpentry terms span, rise, and rafter length are illustrated in the diagram at the left. Carpenter wants to make a roof that has a span of 24, so that's all the way across, and a rise of 8.5. What should the rafter length be? So that's going to be the hypotenuse. The thing to notice here is if we have a span of 24, it's really the half span that we're concerned about. So if it's 24, it's 12 halfway across, and the rise here is 8.5. So there we can see where everything comes from. We can see they filled them in down here. So 12 squared plus 8.5 squared, and you can do that by hand. You can probably use a calculator on some of these. Add them together, and then go back and take your square root of 216.25. You'll need a calculator for that. About 14.7 in this case. So our hypotenuse is about 14.7, and it's going to be feet. So pause, head into class kick, and work a couple. I guess it's just one here. What is the rise of roof span? Okay, what is the rise of a roof span if the span is 22 feet and the rafter length is 14 feet? So something to think about again in this one is we think about the half of the roof, not the entire roof. And so if the span is 22 feet rather, it's 11 feet for the half span. And it already said that the rafter length, which is the hypotenuse, is 14. We're looking for the rise of x. So what that looks like, we have x squared plus 11 squared equals 14 squared. So x squared plus 121 equals 196. Subtract that 121 from both sides, and x squared is 75. So x is the square root of 75. And again, a little bit of calculator fun. X is about 8.7, the label's feet. So I think this is like 8.66, and it obviously goes on forever because it's not rational. So that's what we're looking for there. Continue here for more examples. I mentioned this previously. I'm going to give you 3 lengths. I'm going to say, hey, does that make a right triangle? So you take the 3 and you plug them into Pythagorean's theorem. The biggest number has to be the hypotenuse. That's all there is to it. So 12 meters, 15, and 20. So 12 and 15 are A and B. So 12 squared plus 15 squared equals 20 squared. 12 squared is 144. It's 12 times 12. 15 times 15 is 225. 20 times 20 is 400. Now the left side adds up to 369. That is not the same as 400, so this is not a right triangle. It can be some other kind of triangle, but definitely not a right triangle. Pause here, head into class kick, and work a couple. Okay, so this first one includes a square root already in the work, so I'll show you how that works out. So we got to figure out then, does this work? So we have to figure out, well, 113, the square root of that is, I don't know, 10 point something, so it's between 10 and 11, because it's between 100 and 121, so we know that's the biggest number here. So we fill this out, so 7 squared plus 8 squared equals 113, the square root of that squared. Looks kind of weird, right? So 7 squared is 49 plus 64. Now that equals 113 because squaring a square root just undoes it and leaves us just the number. So on the left side, we add 49 and 64, and we do get 113. And obviously 113 equals 113, so the answer is yes. The second one Obviously 10 is going to be the biggest number here, so we're going to have 5 squared plus 6 squared equals 10 squared. So it's 25 plus 36 equals 100. Well, 61 does not equal 100, so it's no, this does not make a right triangle.